Snakes. Throughout the study of animal evolution, bilateral symmetry has been associated with the more evolved creatures, with only basal animals such as Porifera, Cnidaria and Ctenophora being excluded from the clade of Bilateria. However, some animals can exhibit asymmetric features thanks to convergent evolution, which have found a specific function for that animal. Such features can be seen in some snail-eating snakes present in Asia, which have asymmetric mouths designed to capture, contain and consume snails, which are predominantly clockwise creatures. A study was undertaken by a university in Japan on a subfamily of Southeast Asian snakes, Pariantinae, which feed on snails. These snakes typically have more teeth on the right mandible than the left, therefore exhibiting asymmetric feeding apparatus. The aim of the study was to determine the advantage this differentiation had, which had made it evolutionarily successful. The first thing you need to know about snails are that they're clockwise creatures predominantly, or right-handed. This means that when viewed from the ventral side, the spire, or pointy end, is pointing upward and the opening is on the right. Anti-clockwise or left-handed snails' opening will be positioned on the left, as seen in these images. Similar to us, a significantly smaller portion of the population is left-handed. These anomalies find it more difficult to mate with their right-handed counterparts, which would result in evolution working against them. So why are they successful? The snail-eating snakes used in the experiment were found to have an average of 7.4 more teeth on the right mandible than the left, indicating clear asymmetry, compared to non-slug eaters, which retained a symmetrical jaw. During the study, snails were placed on a wooden pole while the snakes were able to approach from behind. In this video, the snake is approaching a right-handed snail, and it is clear to see it has firm control over the prey. The mandible enters the opening of the shell, and by alternating the left and right mandibles, it is able to extract the slug from its shell. The identical technique can be observed in this next video, but this time with the left-handed snail. There is significantly more struggle observed, and the snake is ultimately forced to drop the prey. This difficulty was exhibited consistently, with an average of 25% lower success rate compared to the near-perfect success rate of the right-handed snails, emphasizing the difficulty with which these snakes have in hunting and consuming them. As the shape of the snail shell was the only variable in the experiment, it can be concluded that the asymmetry found in the mandible of this breed of snake has evolved to make it easier to hunt and consume right-handed snails. However, its hindrance in the hunting of left-handed snails has proved beneficial to the slugs, securing their existence despite their difficulty with mating with right-handed snails.